Tyson, your host of Nova Science Now, where this season we're asking 6 big questions. On this episode, how smart are animals? Meet Chaser. She's got a huge vocabulary.
She knows the name of every single one of these?
And it's not just her. Dogs are suddenly acing some tests that our closest relatives can't pass.
Look at that intensity.
And researchers are finally taking notice.
A dog is like a soldier of science.
Find Crawdad.
If we can figure out how they think, then we'll understand ourselves.
Excellent, excellent, good job.
And a trip to paradise, where some of the smartest creatures, who can even read symbols, are also the most talkative.
These are his clicks.
But what are they saying?
Is a whistle a word? Is it a sentence?
Yes, he's very vocal.
Can we crack the dolphin code? Also,
Water.
communicating with animals is a lot easier if
What's it called?
they speak English.
Shower. Right.
He was at the level of about a 5 or 6 year old child.
This researcher spent her career with one remarkable bird,
How many?
Alex.
2. Good parent.
For 30 years, Alex was the center of my life.
What do you want? You want a nut? You can have a nice big nut.
This is a parrot. How amazing is that?
We were communicating with another species.
Can you tell me what's different? Color.
Are these just parlor tricks?
Find Darwin.
Or are these animals really intelligent?
Chaser hasn't even ever heard the name Darwin.
All that
And more.
on this episode of Nova Science Now.
Funding for Nova Science Now is provided by
It's part of our pop culture to give animals human personalities and talents. Good boy, good boy. Movies and cartoons are filled with talking creatures who basically act like people, but they've got feathers or fur, from Donald Duck to Alvin and the Chipmunks. And when it comes to our own pets, it's awfully tempting to imagine that they have human thoughts and feelings. But researchers have always been skeptical about animal intelligence. After all, we humans speak and write and build spaceships and solve puzzles. Yet animals, well, they're just not that accomplished. Yet recently, as we test more animals and try to reveal the way they think, we've come up with some surprising results. And these days, one of our star pupils is the one animal who may know us the best.
She's a wonderful little dog. She is something special. She's really smart, and we have this connection.
She is extremely intelligent.
I think that she is very much like a person.
Jump.
I think Tucker understands me more than anyone else.
Plenty of dog owners have always said their dogs were smart. But animal researchers are just starting to catch on.
1, 2, 3.
New discoveries are showing that our best friend is smarter than they ever thought.
Good job.
And behind those big brown eyes lies a brain that resembles ours in ways we never imagined.
There.
John Pilley, a chipper 82-year-old,
Come back, hurry.
started working with dogs as a psychology professor.
Walk up, girl, walk up.
Now, he's got one of the smartest dogs around.
Come on, girl.
And I've come to check out what she can do.
Good girl.
Chaser is a 6-year-old female border collie, a breed famously skilled at herding sheep.
She was born to live in the Scottish mountains.
Chase, tunnel.
And herd sheep.
Go, there.
Be a shepherd.
John has taught Chaser to tend an extremely large herd,
That was a sheep.
but there are no real sheep in it.
I can't.
Chaser's herd is made up of toys, about 1,000 of them.
And she knows the name of every single one of these?
I hope.
Sailor.
John has assigned a name to each one.
Never forget. Oh, because it's
and taught those names to Chaser.
an elephant. Okay.
She has about 12 elephants.
Apparently, sometimes John ran out of stuffed animals.
Uh-oh, these are a pair of my shorts.
Oh, my God.
No, that's one of her toys.
John claims that Chaser remembers the name of every single object in the pile. Personally, I find that hard to believe. I don't have time to test Chaser's memory on 1,000 names, but I will test her on a random sample. John and Chaser go into the house so they can't see.
So I'm going to get a handful of toys out of this pile and see if Chaser can identify them indoors. Here.
With John and Chaser out of the room,
All right.
I lay some of the toys out behind the couch.
Inky. There's Lover.
Now it's time to see if Chaser really remembers their names.
All ready for Chaser. Come on, Chaser. Come to Neil. Okay. Okay, come on down. Quick. Chaser, find Inky.
Well, she got one right.
Find Seal. Whoa!
And that one too.
Okay, ready, Chaser?
Now, you might be wondering what's going on behind the couch. Like, is John handing her the toys?
Find Crawdad.
Let's check our hidden camera.
Find Sugar.
I asked Chaser to find 9 toys, and she got every single one right. And remember, I picked the toys randomly from this huge pile. Neither John nor Chaser saw which ones I picked. On multiple trials with John and others, Chaser consistently aces her test.
There's 1,000 toys here. That doesn't, like, spook you?
It makes me happy. These dogs have super memories. On your mark, get set, go! Over.
Chaser and other border collies like her have shown they can remember hundreds of words and what they represent.
Table, reverse. In, out, in.
What's more, they can learn these new words very quickly.
Over. Table, Chase, table. Good girl, good girl.
So how does this ability compare with other species? Well, besides us, chimps and bonobos are the animal kingdom's top linguists, capable of learning sign language, but very slowly. There are tests where dogs perform much better than apes. Consider this simple task. By the age of 12 to 18 months, a human baby knows to look or go where a grown-up points.
What do you think?
This is something that little children do right when they start to acquire language.
Brian Hare is a primate researcher who tried this experiment with some of our closest relatives, chimps and bonobos, with surprisingly bad results.
Primates really struggle. If you try to help them and you try to cooperatively communicate to them about the location of food, they're completely flummoxed. They don't understand.
Chimps and bonobos can solve some sophisticated problems, but they don't always pay close attention to humans. Brian suspected that this was one test where dogs could do better than the apes. Sure enough, when dogs were brought into the lab, they got the point.
So dogs, on the other hand, are really good at this. If you say, hey, the treat's over there, the dogs, they're really good, and they go find the thing. And relative to primates, it ends up dogs have a very special ability.
For Brian, the experiment highlights a basic difference between the way that dogs and bonobos view humans.
Come here. When I see my dog wants me to be around. He wants me to be his social partner. He actually needs me. Whereas a bonobo and chimpanzee, they don't need me. They're basically like, hey, you got any food? Can I get any food off of you? Is there something I can do to trick you, to teach? No? Okay, well, I'm gonna go stay with my fellow bonobos and chimpanzees. They're not interested in making me happy.
Compared with primates, dogs are ideal research subjects because they love to cooperate with humans.
Good girl.
dog is like a soldier. They're like a soldier of science. They show up and they're like, yes, sir, I'm here to play. Let's do this game. Let's find out how my mind works. You know, is that a biscuit? Okay, I'm whatever you need.
So even though primates like chimps and bonobos have bigger brains than dogs and are genetically much closer to us, Brian suspects that in some ways, dogs' social intelligence might be more like our own.
Yes, you're a good boy.
That's one of the reasons why he and other primate researchers have recently started up new dog cognition labs.
Tazzy.
If we can figure out how they think and why they were shaped the way that they were, then we'll understand ourselves.
Look at that intensity. Look at that focus.
They're truly amazing.
So how were dogs' minds shaped?
Good girl.
Dogs evolved from wolves. Brian believes that something crucial happened to the dog's brain during that evolution from wild animal to pet that allowed it to pay closer attention to another species, people.
It's an exciting idea that somehow dogs, during domestication, are shaped during tens of thousands of years to be able to read our social cues in a way that allows them to survive with us.
I met my first wolves at Wolf Park in Indiana, where I visited with animal psychologist Clive Wynn.
Hey, we're coming to see you now.
These are among the tamest wolves in the world, raised by people almost since the day they were born. Still, we're warned to be extremely careful around them and not make any sudden movements.
Wolves still can have very violent fights with people they are friends with, and that's why it's not wise to try and make pets of wolves.
But I also get the sense that they know, in their head, you can see them thinking it. It's like, I could rip your throat out if I wanted, but I just choose not to at this moment.
They still have a more violent kind of social life, and they have very powerful jaws, and they can really do you some serious harm if they decide that you and they are now in some dispute about something. Dinner, for example.
Wolves, relative to dogs, are much more emotionally reactive around humans. So there really seems to have been evolution. There's been selection, actually, for dogs to be really interested and tolerant towards people.
Dogs are much less volatile than wolves. Brian thinks their emotional tolerance is what allows them to pay closer attention to humans, and as a result, makes them more flexible students.
Chaser, fine meal. Fine meal.
Take Chaser, John Pilley's brainy border collie.
Good girl.
Let's see what she does when we challenge her with a new toy she's never seen or heard the name of.
I smuggled this into your house.
It's a Charles Darwin doll.
Okay, so I put 7 toys behind the couch, plus Darwin. Chaser's never seen Darwin, hasn't even ever heard the name Darwin. So we're gonna see if she picks out Darwin by inference. That's what we're gonna check. I'm gonna call her down now. Chaser, come on back. Let's have some more fun.
First, I'm gonna ask Chaser to find a couple of toys she already knows.
Find Sugar.
Excellent, Chaser. Chaser, good.
Okay, put in a bin. Find Quadad.
Excellent, excellent, good job.
Okay, put in the tub. Put in the tub.
Okay, here it comes. A name she's never heard before.
Find Darwin.
So while searching for the other toys, Chaser knew exactly which one to pick up right away. But now, she seems to have to think about which one might be Darwin. It's taking her longer. She takes so long, I call her back.
Chaser? Find Darwin. Find Darwin.
Finally, she makes a choice.
Darwin! It got Darwin!
I can't believe it. Chaser's never seen that doll before.
Darwin! That's Darwin! You're a good girl!
Yet somehow, she made the connection. that the name she'd never heard before
You found Darwin.
went with the one toy she didn't recognize.
It's a good girl.
Chaser's not the only dog to do this.
That's Darwin.
And what's more, dogs like Chaser have shown that they will remember the connection they made between new name and new toy. This is yet another way they can learn.
What's interesting about seeing how dogs are learning these new words is that people thought this was really unique to humans, that this was something that was, only humans do this. But it seems that no, that's not the case, that dogs can make these inferences about what novel utterances mean, and they can remember them for quite a long period. Now, this looks just like what little children are doing. And so it's remarkable because the flexibility we see in dogs seems to be very similar to what you see in young children at a very important age in their development.
Dog research is just getting started. But hopes are high that this animal, so long ignored by science, may give us new insights into how learning works and offer a unique window into the evolution of the mind. When we see animals doing remarkable things, how do we know if we're simply seeing tricks or signs of real intelligence? Are talented animals just obeying commands, or do they have some kind of a deeper understanding? One of the biggest challenges for animal researchers is to come up with tests that can distinguish between the two. Correspondent Doug Hamilton traveled to a Caribbean cove to find out if some of our favorite performers are merely good at taking direction, or if they're smart enough to put on a show all their own.
This is not your typical science lab. It's a beautiful scuba diving resort called Anthony's Key. I've come here to meet the 24 Caribbean bottlenose dolphins that are in residence. Think of this as a really pretty school for dolphins. Terry Bolton is their head trainer. She shows me the ropes.
Finger up first.
Finger up first. And the way to a dolphin's heart.
You reach into the bucket and very gently drop it into his mouth. Down the hatch.
They got a lot of teeth in there.
They do.
Terry's trained the dolphins to do some pretty impressive things. And they seem more than happy to show off for me.
Are you ready? Yeah, we're ready. You sure? No. Come on, boys. They are amazing animals. They're very curious. They're very bright. So what we try to do as trainers is teach them the love of learning. Turn and go. We start every training session off on a high, and we want to leave it on a high. We're all about positive reinforcement. They love to be correct. Doesn't everyone? I just love it.
You cheer them on like you're playing with a dog. Is that what you're doing? Is that you're just encouraging that behavior?
Hey, that was better. I think we cheer them on like they're our kids. And you can see how they respond to that. You can see the brightness in their eyes. You can hear it in their vocalizations. They respond to that joy.
Terry says that one of the best ways to experience the dolphins' world is to just dive right in. Right into their world.
Dolphins are so well adapted to life in the sea. Their brains have evolved to a higher level where they can play and create and problem solve.
A big challenge in figuring out how smart dolphins are is that their world is just so different from ours. Their brain even has powers ours does not. To prove this point, Terry asked me to bury a ring underwater outside of the dolphin's enclosure. Without being able to see the ring, Terry or any other human would have a very hard time finding it.
Mission accomplished. They'll never find it.
So she sends in Paya, the oldest male dolphin. They give him the command to find the ring. The audio on our underwater camera picks up Paya making a clicking sound.
He's really searching hard for it.
But this is more than just a noise. Dolphins can detect their sound bouncing back to them to sense their surroundings. Paya uses echolocation, like sonar, to track down the ring.
He outsmarted me.
Good!
The dolphin brain is large. In fact, relative to body size, it is the second largest only to humans, and is one indicator of their potential brain power. Terry puts those brains to the test with an activity we humans clearly associate with intelligence: reading. Can dolphins understand a command by reading a symbol? Looks like they can. Watching these dolphins, it seems perfectly clear to me that they're really smart. But what do the scientists think?
Are dolphins really intelligent? Yes, I definitely believe that that's the case. But in fact, I think we've just scratched the surface about what dolphins are really capable of.
Stan Kuchai runs the Marine Mammal Behavior and Cognition Laboratory at the University of Southern Mississippi and is working to analyze and prove just how smart dolphins are.
Put your finger back up.
Finger up.
Sway.
We've been watching these animals do amazing things. But how do you know if they're doing something that's really just a rote learned behavior versus doing something that actually shows how smart they are?
That's a really good question. Dolphins learn to do a flip on command, and they learn to associate a trainer's signal with that behavior.
Yay! Good job!
But a more flexible problem solving is when they can actually be a little bit more creative. That shows intelligence much more so than the rote learning does.
To see if dolphins could handle more than just rote learning, Kuchai devised an experiment a few years ago to test a dolphin's ability not just to follow directions, but to think things through and plan ahead.
Planning is a real hallmark of intelligence.
The dolphins were trained to pick up a weight and to put that weight in a box. They learned that if they put enough weights in, a fish would come out the bottom. The dolphins quickly figured out that they could get the fish faster with a lot less work by gathering up multiple weights in one trip.
If you can plan, you can decide what course of action to take without actually having to try it first. That enables you to avoid a lot of risky situations and to be much more adaptable.
Dolphins are social animals. They travel in groups. So can they plan together?
I've seen dolphins in the wild, and all of a sudden, all the dolphins get together and do a deep dive together. Obviously, somebody's coordinated that behavior.
How do they do that? Are they actually communicating? It would help if we could just ask them.
What are you saying?
Now, they make different sounds.
Yeah, French is yes, he's very vocal.
Show me the difference between a click and a whistle.
Here's his whistle. And these are his clicks.
Scientists think these clicks and whistles could be the building blocks of a language. But no one has yet figured out how to translate them.
Yeah, you have a lot to talk about, don't you, mister?
Stan and Terry have devised an amazing two-step experiment. It's designed to test whether dolphins are just trained performers, or can they plan and come up with tricks of their own?
Ronnie and Bill forward, Richie and Paya from shallow to way back.
First, the dolphins are asked to learn a concept, to create a trick of their own, not just a rote behavior. Now, Stan and Terry are upping the ante. They want to see if their two-star dolphins, Ronnie and Bill, can create something together. This means the dolphins are going to have to think, plan, and hopefully communicate.
So you're building them up now to the big moment.
Okay, we're gonna do create this time. Ready? Fingers up. Together. Create.
Underwater, Stan gets the dolphins' view of things. His camera is also recording any sounds the dolphins make. Sure enough, he hears their signature whistle.
Go, go, go! Did you see that? They went on their backs and they lifted their tails.
That's really cool.
That's monumental. They've never done that before.
It appears that these dolphins can do a lot more than just rote learning.
It's really impressive because the animals have to understand the concept of do something different, and they have to be able to keep track of what they've done.
Do we know of other species of animals that can do this?
As far as I know, other than humans, dolphins are the only ones that can do this.
The big question now is, can this experiment help crack the dolphins' code?
We know they produce lots of sounds. But is a whistle a word? Is it a sentence? Is it a paragraph? Does it express an emotion?
You're looking, in a sense, for the Rosetta Stone of dolphin communication.
Yes. It would be really nice to find that. So if you're diving and you find that, please bring it up.
In the animal kingdom, one of the keys to survival is to outwit your enemies. And when you're surrounded by carnivores, one of the best strategies is to fade into the background and disappear. Correspondent Jake Ward met some animals whose mastery of disguise is so sophisticated it could be a sign of a surprisingly complex brain.
When it comes to animals, we humans tend to think we know which ones are the most intelligent. Our own pets.
Give me 5.
Good target. Oh, good target. Good boy.
And most of these smart pets have one thing in common. They're all mammals, just like ourselves. But invertebrates, they don't get much respect. Take mollusks, for example. It's hard to imagine a whole lot of mental activity in a clam. But get ready to meet the Einsteins of mollusks with their incredible brains. The cephalopods, cuttlefish, squid, and the amazing octopus.
It's this wily creature with 8 arms, 200 suckers per arm. Every sucker is highly malleable. They have enormous brains, and there's a lot of complexity there, including intelligence, cognition, and it's the big brain that imparts that.
Here at Biomes, an aquarium and science center in Rhode Island, educator Mark Hall has been studying one of his star attractions, Ruby the octopus. And by the way, Ruby is a boy.
Octopuses are absolutely smart. They exhibit intelligence. I see them problem solve, which is the most impressive part. They teach themselves how to fix problems. There's a lot of signs of intelligence there, without doubt.
One problem Ruby has learned to solve is unscrewing the lid on a glass jar that holds a tasty little shrimp.
Here's a jar. He knows it has food in it, but there's a cover on it. I don't teach him how to take the cover off. I give it to him and say, go ahead, see what you can do. And at the beginning, he would twist it the wrong way and tighten it. And he used to do that about half the time, which makes sense, right?
Right.
And as time went on, he did it less and less often, until now, he never twisted it.
Now he's like, lefty loosey, I got this.
It's learning from its successes and its failures, and that's definitely problem solving. Want to try it?
Yeah, I do. Can I try that? All right.
All right, so you're going to just put it in the tank.
Right. Oh,
There you go.
oh, there it goes. Whoa. Holy cow.
All right, now he's reaching in.
Whoa.
Placed
The
it right into
shrimp
his
never
mouth.
had a chance.
Do you notice he's holding the cap?
Right.
And see the arm, making sure
I
there's
love
nothing
it.
in the
He's
jar.
He's
Yeah.
double checking. He just hangs onto the cap like a guy who twiddles his fork for a while after he's finished eating. Wow. But it's one thing to solve the problem of eating lunch.
Think of it that way.
It's another to figure out how to avoid being lunch. So these cephalopods have evolved a way to avoid being attacked in the first place. They use brain power to create camouflage. Check this out. A predator prowls a reef. His eyes miss nothing. His teeth are razor sharp. And he's hungry. Roger chose to study a cephalopod called the cuttlefish.
Made this decision?
He zeroed in on one component of their camouflage, the pattern. And Roger now believes he's found the secret. They simplify their choices by using just 3 pattern types. Uniform, which has very little contrast. Mottled, which has light and dark bits. And the one with the greatest contrast, disruptive.
You want to go from uniform to...
To control the area and contrast the animals are exposed to, Roger places them against backdrops they would never encounter in nature. Hello, buddy. With each one, the animal changes its pattern, usually in mere seconds. Uniform, mottled, disruptive.
Look at that, and there.
Well, the animal changed magnificently.
Immediately.
Wow.
So it's created a mosaic out of itself.
I noticed that the white square on its back is roughly the same size as the checkerboard pattern.
Yes.
So if this were a bigger cuttlefish, you'd need a bigger checkerboard pattern to set this off.
Yes.
The animal's brain measures the amount of contrast in its surroundings and then alters its skin to display a similar amount of light and dark.
We say this is a window into the brain because the skin is a representation of the neural activity. This takes a lot of neural processing, takes a lot of decision making, and this is what we call cognition and thinking, and it all translates into some form of intelligence.
Intelligence. Someday we'll have a better understanding of how it enables cephalopods to change their physical appearance so radically, and how they use their brains for other tasks we're just beginning to identify. Recently, Australian researchers documented what looks like evidence of the ability to plan. An octopus in the wild, making a tool out of a found object, a coconut shell, and planning how to use it, for shelter as well as disguise. Maybe, just maybe, cephalopods are more intelligent than we realize.
There aren't many science celebrities, but sometimes somebody working in science has so much personality and charisma and makes such an impact that when they pass away, people are left distraught. In this episode's profile, we meet someone who's made major contributions to our effort to understand the animal mind, and whose unexpected passing has left a hole in the field of animal studies. On September 6th, 2007, Alex died.
I don't know if it's a good analogy, but when Michael Jackson died, many, many people felt a deep loss. It was the same when Alex died. For me, it was actually worse.
I guess I could compare Alex to Albert Einstein.
I read about Alex's passing in The Economist. There's a page at the end, one obituary, and it's only when somebody like really big dies, like somebody who changed the world in some way. And it was Alex the week that he died.
The outpouring, boxes and boxes and boxes of letters, thousands of emails.
Alex was a parrot.
Alex, what toy? Nail. Nail, that's right, you're a good birdie. How many?
And arguably the most famous bird in the world.
2. Good parrot. Good boy. 1, 2.
This is the story of his owner, Dr. Irene Pepperberg,
You be good. You be good.
a rebel scientist whose amazing relationship with Alex
Bye. Bye.
showed that parrots were not only smart, but their mental skills could actually rival young children.
I love you. Love you too. Bye.
When people were saying, no, 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 birds can't do this, and I went, but birds can talk. I know they can talk, and they're smart.
Good boy. What shape? 4-corner. Good boy.
So when I said, oh, a parrot's going to do this with a brain the size of a shelled walnut, the first grant proposal came back asking me what I was smoking.
Growing up in 1950s Brooklyn, Irene initially set out to study chemistry, first at MIT, and then as a graduate student at Harvard. But in 1974, halfway through her PhD, a new television series changed everything.
Nova. Each week, a science adventure.
Say rock. Rock. Say rock. Good boy.
And so there was this ape using sign language, clearly not at the same level as an adult human, but we were communicating with another species. It was the Dr. Dolittle moment.
With her PhD in hand, Irene turned her back on chemistry and set out to begin a career in biology at Purdue University. Her first stop? The pet store.
I had the fellow working with the birds choose one. That way nobody could argue that there was anything special about the bird that I chose. He was just one bird in a cage. That was my first introduction to Alex.
Irene began teaching Alex the names of different objects.
What is it? What's here?
But it didn't always go smoothly.
Unfortunately, the thing that he liked the best was paper. And puh, without lips is really tough.
What is it?
So for a very long time, we had A-R.
And some mornings, he'd work really well. Some days, he was in a bad mood. And me and Dr. Pepperberg could tell because he would give you the look. That's what we called it, the look. He would like turn his head and stare at you and look at you. And it's like, oh no, he's not gonna work today.
If he asked for a banana and you gave him a grape, he'd just toss it at you and go, want banana? As though, how could you not understand him?
Want to try again? Nice and clear?
Training Alex didn't come cheap,
How many?
and Irene's time was consumed by writing grant after grant.
Grant writing is an art, and you learn that art by getting a lot of grants rejected.
You propose something that's sort of unusual. There's a lot of skepticism out there because people don't know if you're brilliant or if you're crazy.
September of '79, the first grant came through.
Irene had to design a study that could prove what, if anything, Alex was thinking.
How many corners?
She developed a training method for Alex that she called the model rival technique.
So we had the object the bird wanted. I showed it to the student who was the model for the bird's behavior. Its rival for my attention. I'd say, what's this?
Three.
Corner.
Good.
Three.
Good. You're right.
And she'd scratch herself the way the bird would. And the bird, of course, would really, really interested. And we'd play that same game back and forth. And then we'd show it to the bird.
What shape? What shape?
Corner.
Good birdie. How many? Good boy. Good parrot.
Irene and Alex worked a grueling schedule of 8 to 12 hours each day.
Banana.
Right. Good boy.
But he embraced the perks of a full support staff and a steady stream of fresh fruits and vegetables. All organic, of course.
What made him special was those first 15 years or so of being an only bird and being the center of everyone's attention and being treated like a toddler.
What do you want? You want a nut? You can have a nice big nut.
He was very inquisitive in that he, if something came into the lab, he'd ask you, what color?
What color?
What shape? What's that?
Orange.
Orange. Good birdie.
Now that she could communicate with Alex, she performed study after study to test his intelligence.
The next breakthrough was on concepts of same and different. And this was something that really people thought that only children and that maybe apes could do. I could show him a number of different objects and ask lots of questions about them. Can you tell me what's different?
Color.
All right. Can you tell me what's same?
Shape.
Good boy. What color bigger? You know, what color bigger?
Yellow.
Good boy. Good birdie. When you think about some of the tasks that Alex did, they were all built on something an animal had to have in the wild. Can they recognize same and difference? Well, they have to recognize this is the same type of berry that I ate last time that was really good. That is part of the animal's basic abilities that they have to have in order to survive.
In 2002, Irene and Alex moved to Brandeis University, and she continued gathering evidence,
How many corners?
trying to prove that Alex understood what he was saying.
What Alex does that's different from parroting is that he recombines his symbols. For instance, someone brought birthday cake into the lab, and Alex knew the word for bread, and he knew the word yummy. And he tasted the birthday cake, and he said, yummy bread.
This is a parrot. How amazing is that?
And it was that moment of realizing that, yes, my hunch as to what he could do was correct. And that moment of knowing something that, nobody else knew. Just for that moment that we had succeeded, we had this piece of information that we could then share with the rest of the world. It was really exciting.
By 2007, Alex could count to 8.
What color number bigger?
Orange.
Orange is right. Good boy.
do simple math,
What is it?
You tell me.
and he knew over 100 words.
Water.
Oh, yeah, it has water in it. Right. What's it called?
Shower.
Right.
So we were able to show that on the types of tasks you give a child, okay, not particularly on language, but on cognitive processing, on number tasks, and, shape questions and things like that, that Alex was at the level of about a 5 or 6 year old child.
Alex and Irene had become stars with an international following. And at 31, almost half the average life expectancy of an African gray, he had just begun to tap his potential. Irene was starting even more advanced tests, spatial relationships and response to optical illusions.
I'm gonna put you in. Okay, you be good.
Bye.
Bye. Alex and I had a good night routine that we used every night.
I love you.
Love you too. Bye. We walked out the door, fully expecting the next day to be just like any other day. But it wasn't.
I got a call from Irene. As soon as I heard her voice, I knew something had happened. And I said, what happened? And she said, I just found out Alex died. And I just froze.
And that's when the phone calls kept coming in. Is it true? Is it true? Is it true?
I was in shock. Alex was just so special.
It was like this emptiness.
Everybody was known to see Alex and her together. Now there's not Alex.
I lost my closest collaborator, my closest colleague, and it was like losing a child, like losing a spouse. I mean, it was just this huge hole, because for 30 years, Alex was the center of my life.
Today, Irene keeps her memories of Alex, including his ashes, nearby. But she's also looking to the future and continuing to work with 2 younger birds.
How many? 1. Oh, that was a very good one. Here's one corner. Here's one corner. Good birdie. Now, what shape is this? What shape?
And her fight for acceptance and funding continues.
Irene's always on the road, trying to raise money.
And it was only at the last 6 months or so of Alex?
Trying to write grants, trying to get donations.
Alex has helped us recognize that animal intelligence is a continuum, so that these creatures that look so different from us are doing the same kinds of intelligent behavior that we are. People now should look at the term bird brain as a compliment.
And now for some final thoughts on smart animals. Smart pets are the ones that obey simple commands and, as we've seen, can memorize the names of things. Smart chimpanzees even know how to stack boxes and reach a banana, or combine hand gestures into rudimentary sign language. These animals are cherished by their owners and are often the marvel of scientific conferences. Though impressive for their own species, their intellectual talents are no greater than that of a human toddler. Our brain is, of course, capable of art, poetry, philosophy, mathematics, technology. Meanwhile, only a small genetic difference separates humans from other mammals, especially chimps. What a difference that little bit makes, you might say. But suppose that intelligence difference was as small as the genetic difference itself, and we just tell ourselves it's large. Suppose another life form showed up with the same small genetic advantage on us that we have on chimps. What would we look like to them? The most brilliant among us, say Stephen Hawking, would be presented at their conferences as they proclaim, "This one is slightly smarter than the rest. He can do astrophysics calculations in his head, just like our little Timmy over here." Come to think of it, we've never meaningfully communicated with a species on Earth less intelligent than we are. Could it be that our simplest thoughts are too abstract, too complex for them to comprehend? Leaving me to wonder whether this hypothetical smarter life form would be similarly challenged trying to communicate with us, as they wonder whether their simplest thoughts are too abstract, too complex for the human mind to understand. And that is the Cosmic Perspective. And now we'd like to hear your perspective on this episode of Nova Science Now. Log on to our website and tell us what you think. You can watch any of these stories again, download additional audio and video, explore interactives, hear from experts, and watch revealing profiles of our web-only series, The Secret Life of Scientists and Engineers. Find it all at pbs.org. That's our show. We'll see you.